everybody. I'm Kikuchi, Chairman of CIP Japan. Dear Principal, Vice Principal, teacher, parents, and students, I am so happy to have the opportunity to conduct our STEM robotics education for students college Kandy. CIP Japan has a very nice experience for 23 years. Please see my STEM robotics education video.
Hello everybody, I'm Kikuchi, Chairman of CIP Japan, Tokyo. As you know, day by day, we are using a lot of AI, artificial intelligence, IoT, Internet of Things, robotics, big data, and other new technologies like 5G network. Under this kind of our life environment, the innovative mind is very, very important for students. To improve innovative thinking, STEM education is a trend and is deploying in the world. STEM stands for Science, Technology, Engineering. We CIP Japan are conducting STEM robotics way education from 22 years before. We deployed our STEM education in Japan, US, Singapore, Thailand, India, and Sri Lanka. Please enjoy our unique STEM robotics education. Thank you very much.
Because of the pandemic situation, students could not go to school, so we are conducting online STEM robotics education using simple materials such as paper, cardboard, and other materials. And students gain problem-solving skills and creative skills. Please enjoy this virtual exhibition. Thank you very much.
Hello everybody. Today we would like to introduce a new education program called STEM Education through Robotics. STEM stands for Science, Technology, Engineering and Mathematics. Let's start. The purpose of the STEM Education through Robotics program is to enhance each child's ability to utilize their knowledge of each subject to connect to the real world, our lives, as well as to solve problems. It has been implemented in many kindergartens worldwide. Children here are thinking about the colors of the blocks as well as the design and shape of the object they are making using the blocks, and learning the basic mechanisms of how mobiles and seesaws move, etc. These photos show how students in the lower grades of elementary school learn. They learn the mechanism of physical phenomena, electronic circuits, etc. through experimental programs. Then, children in the higher grades of elementary school design and make robots using computer systems. They can apply their knowledge of science, technology, engineering, and mathematics to the real lives and improve their problem-solving abilities. STEM education through robotics is being implemented globally, such as in the US, Singapore, the Philippines, and Thailand. The children are engaged in building things with their favorite Lego bricks. Teams are immersed in the practice rounds. Teams and coaches know that an over-reliance on oil causes global warming and environmental disruption, so they decide to use a water deck. Teammates cheer as they successfully complete a robot in the live robot performance. At the third annual White House Science Fair, President Barack Obama emphatically stated that one of the things that he's been focused on as president is how America can create an all-hands-on-deck approach to science, technology, engineering, and math. He said that Americans need to make this a priority to train an army of new teachers in these subject areas and to make sure that all Americans as a country are lifting up these subjects for the respect that they deserve. The Obama administration stands committed to providing students at every level with the skills they need to excel in the high-paid, highly rewarding fields of science, technology, engineering, and math, STEM. That's why the President launched the Educate to Innovate initiative to move American students from the middle to the top of the pack in science and math achievement over the next decade. Now we would like to introduce Dr. Nomura, Professor of Robotics at Saitama University. He is a leading authority in the area of robotics and has been executing the STEM Education through Robotics program worldwide. Let's listen to his explanation about the methodology of STEM. What are the differences between STEM education and usual education?
There are three major differences between our STEM education and usual education method. The first is the importance of authentic learning for students. Usually at schools, the teacher teaches the students and the students do the majority of their main activities such as writing or listening at their desk. But in the STEM education method, importance is placed on not only what the students are learning, but also how the students are learning. This means that in STEM education, the teacher is not a teacher, but acts as a supporter for the student learning. This is the first point. The second point is the importance of making things. Usually, students learn about subjects by reading and writing at their desks. However, in the real world, we do not just memorize their knowledge, but we use our knowledge and skills to carry out our daily activities. Typically, making things contains this kind of activity. For authentic learning, we have to give the students the chance to think about real problems. So making things enables the student to think. The third point is engineering. The E in STEM stands for engineering. Usually, an engineer's activity involves solving a problem. This means that engineering is mostly equal to problem solving. In usual school education, science, mathematics, or other subjects just cover the knowledge related to each subject. However, in the real world, people combine and use this kind of knowledge altogether to solve their problems. This behavior itself relates to the engineering area. This means that in the STEM education, the engineering concept is very important.
Do you have any evidence of STEM's effectiveness?
For our practical research, we try to introduce how the STEM education relates to science in the 4th grade of elementary school. Before our practical research, students had already learned about electrical circuit in science, and we did some paper tests to check their knowledge and about electrical circuit, which they had already learned about in their science lessons prior to the practice. The result was 80% of the students had correct knowledge about an electrical circuit, but 20% still seemed confused. However, during our practice, students try to make robots that use electrical circuit and motors. During this activity, students recall their learning in science. After that, we conducted another test to check their knowledge of an electrical circuit. Finally, almost 100% of the students have stable knowledge about an electrical circuit. This means that through the STEM education, students were able to make a strong relationship between real problem solving and the knowledge they have acquired in the past. We can say that STEM education is successful at enabling students to be able to create links between their school knowledge and real-world problem-solving techniques.
STEM methodology is extremely helpful for children to find solutions to solve problems by themselves, and it is very effective for a child's growth. Thank you.
Hi everybody, I am Sayumi Valasundara of Grade 6 Hillwood College, Kandy. Today I am going to talk about my special assignment in the subject of STEM. This is a basic structure of one of the modern irrigation systems in the world. I have named this project as a model of drip irrigation system. Let's talk about a few things on history of drip irrigation system. The drip irrigation system is discovered by the Jewish people in Israel during the period of 1959. This basic invention became the world famous later on. This has been developed by them with the newest technology. As of now, and most of the countries are using for their agricultural irrigation purposes. The basic theory behind this model is storage water on a higher place and provide only the requirement of plant as a little drops of water. Let's have a look on how to identify the parts on it. In order to keep stable on the ground, I used a wooden frame like this, a plastic bottle as a storage tank, a funnel to pour water, a coconut fiber thread to deliver water to the plant, another plastic container as a media of plant, 2 green ground plants and water. Let's have a look on how it's work. First, we need to pour required amount of water into the plastic bottle. The bottom of the bottle has a small hole for the water to drain out. The hole is fitted with the pieces of rope made of coconut fiber. The water applied from above flows down this rope as a small stream of water and drops near the plant as drops of water. Finally, let's look at the advantages of this type of systems. The biggest advantage which we can save water, as well as this could minimize the wastage of water. Plants get only required amount of water to grow, optimum level since we can control the water level. The system can add fertilizer as well with the water. The plant retain high quality feed. No electricity or any other power needed to operate this system because it works by gravity pressure. These type of systems are more suitable for the areas which have a limited amount of water. Thank you. College Kandy. I'm recording this video to explain how my project works. This project is a simple water irrigation system. I made the structure using a few simple things that I could find at home, such as this paper cup, a toilet roll with aluminum foil, 2 paper straws, cotton thread, and this disposable plastic container. So this is how I made the product. I took the toilet roll and I wrapped it in aluminum foil. Then I pasted the paper cup onto it. Then I took the 2 paper straws, and because I didn't have the plastic bendable straws, which would have come in handy by then, I used tape to cover the straws. One reason to make it more waterproof, and the second reason is because that would make it easier to join together. At the end of the 2 straws, I blocked it so that the water which I put in here won't just flow out of there. Then I took a needle and I poked holes over here in the straw, through the straw, and I passed through some thread, and I took the edge of the thread, the end of it, and I buried it deep inside the soil so that when the water goes through here, it should go down this thread and roll over the roots of the pot. I had 2 reasons to fix the straw at the bottom of the cup. The first reason is because the water pressure will build up at the bottom of the cup, which will make the water flow faster through the pipes. The second reason is because even if this system has to run on a low water level, you'll still be able to use it. Also, the reason why I placed the cup on the tissue roll is to get the necessary height. So now that we know how my project works, let's try it out. The name of my game is Shark Attack. In this game, the shark chases the fish, and when the shark gets the fish, it says "got you." And when lives become 0, it's game over. For this game, I used motion, looks, sound, events, control, sensing, and operation blocks, and I made a new variable called lives. This is how my game works.
My name is Vinudhi Ekanaik and I am in grade 6-4. I made a parrot game using the app Scratch. I used motions, looks, sounds, events, controls, sensing, operations and variables to make the Scratch game. Using the arrow keys, you can move the parrot. To get points, you should move the parrot using the arrow keys and collect coins. As you play the game, your score is shown in a box to the left corner of the game. Thank you.
Hello, I am the 1,000-year Princess Emily. I will run with the country and glory 1,000 my kingdom. My stallion, it looks like the world has collapsed on me. What is wrong? You panicked my ducks. You said the Eden Fairy is back. But that's not what you said, right? There is no time to lose. The king is being busy. Come on, Stallion, you must leave me. The Princess Lily! She has come to save us! Hip hip! Hooray! Hip hip! Hooray! Why, my subject, you are going to see me feel. Have you seen the wicked fairy? You know what happens is they were just deepens all of us citizens. We must now leave, my stallion. Stay here, I will only see you.
Everyone, today I am going to present convection of heat. Heat is form of energy. Heat transfer from high temperature to low temperature. There are three types of heat transmission. They are convection, conduction and radiation. Today I am going to present convection of heat. That is heat transmission in liquids. We need 2 glasses, color, a CD and cold and hot water. Let me pour some cold water into the first glass. And hot water to the other glass. Add the color into the hot water. Let us take a CD and keep it on the cold water. Hold it properly and flip it on the hot water. what you can see? You can see that the hot color water is rising upwards. This happens because the hot water is less dense than the cold water. This is known as convection mode heat transfer. Convection is the transfer of heat through gases or liquids from a warmer spot to a cooler spot. We just now saw that the convection current was moving upwards. Do they always really go upwards, or could they move downwards too? Let's not check that by keeping the hot water glass on the cold water. First we pour some cold water to the first glass. And hot water to the other glass. Add some color to the hot water. Take the CD and keep it on the hot water. You can see that the convection current always moves upwards and not downwards. Here you can see clearly the color water and the cold water are separated. These experiments show us that convection current always moves upwards. Thank you. By Lakiti Gunasekara, grade 6-3.
Hi, I am going to demonstrate convection of heat. This happens when there are differences in temperature between two parts of a fluid. When this happens, hot fluids rise and cold fluids sink. This causes movements or currents in the fluid. For the experiment, we need colored ice cubes and a glass of water. First, take few colored ice cubes. Then, take a glass of water. Put the colored ice cubes into the glass of water. We can observe that the color goes down. Now, we will see how this is happening. The temperature of the colored ice cubes is low. The temperature of the water is high. The warm water melts the ice cubes, so the colored water pushes down to the bottom of the glass. Water has warm air mass, and the colored water has a cold air mass. As fluid warms, it gains kinetic energy and moving faster and farther apart. This decreases the density of the fluid near the heat source and becomes lighter. The warmer, lighter fluid rises and cooler, denser fluid pushing down. Now, I am going to explain few examples of convection in every life. sea and land breeze. In the evening, air near the land is warm and it is replaced by cool air of the sea. Boiling water. Cold water at the bottom heats up from the burner and rises up. As hot water rises, the cold water replaces into hot water. Blood circulation in warm-blooded mammals. The heat generated by the cells in the human body is transferred to air or water which is flowing over the skin. Air conditioner. The AC released cold air. This cold air is denser than warm air and it sinks. The warm air rises and the room gets cold. There are some more examples. They are hot air balloon, refrigerator, hot air popper, rainfall and thunderstorm. Thank you.
Good morning, my dear teachers and my dear pets. Today, I'm going to talk about the scratch calculator. As you see, I have used two variables called A and B and four blocks from operators that are named as blank divide blank and blank add blank and blank multiply blank and blank subscribe blank. Okay, first let's try blank divide blank. In the blanks I'm going to put A and B. Now let's try it out. Tell me the first number. I'm going to put here 56 and the second number is 7. Yes, it's correct. It's 8. Now let's write blank multiply blank. In the blanks I'm going to put A and B. Now let's try it out. Tell me the first number. I'm going to put here 20 and the second number as 2. Yes, it's correct. It's 40. Now let's try blank and blank. In the blanks I'm going to put A and B. Now let's try it out. I'm going to put the first number as 100 and the second number as 89. Yes, it's 189. Now let's try blank, subscribe blank. In the blanks I'm going to put A and B. Now let's try it out. I'm going to put the first number as 100 and the second number as 3. Yes, it's correct. It's 97. Okay, so our scratch calculator worked correctly. Okay, now let's talk about how to draw a polygon in Scratch. Sum of the exterior angles of a polygon is 360. The formula for calculating the size of an exterior angle is exterior angle of a polygon equal 360 multiply number of sides. So let's draw the diagram. It's real nicely. Bye.
My barometer project. Things we need: glass jar, cardboard, straw, pair of scissors, rubber band, balloon, tape, ruler. Step 1. Cut the straw. Step 2. Stretch the balloon over the jar. Step 3. Keep the straw on the balloon and fix it with tape.
Step 4. Keep the jar and the scale empty on the table. The scale should keep horizontally, or you can place the scale on the wall. 2. First, mark the current position. Take the point where your straw shows as the middle point and the current position. Then use a ruler and mark above and below from the center. It is better to do this in a sunny day. How does it work? After we cover the jar with the balloon, the air pressure inside the jar and outside the jar are equal. When atmospheric pressure decreases, the pressure inside the jar is higher than the outside. So the balloon rises up and straw goes down. When atmospheric pressure increases, the pressure inside the jar is lower than the outside. So the balloon goes down and straw goes up. What does it mean? When air pressure drops, probably bad weather is on its way, so it means storm, rain, clouds, and wind in the area. When the air pressure increases, it means that the weather is good. You will have a sunny and clear sky. That is how you measure the air pressure and predict the weather by using barometer. Thank you.
Good afternoon, everybody. So I'm Sadinsa Kurupu from grade 7. So I want to produce electricity from batteries. For that, I made a windmill like this. I have used 2 battery packs, 1 switch, 3 LED bulbs, and at last I have used a motor. I wasn't able to supply electricity to all these 3 bulbs and motor by one battery pack because I have used a parallel circuit system. Because of that, I have used 2 battery packs, and this battery pack supplies electricity to this motor. So here are the batteries, and current comes through this battery to this switch, but I have switched off this switched off, so this is a barrier to the path of the current. But when I switched on, it works. That is because the current passes through this switch and goes to this bulb, then to this, and then to this white bulb, and at last to this motor. So why it is happening like that? First, the batteries. You know, the batteries are made with chemicals and some other things. Then the switch. You know, the job of the switch is connecting and disconnecting current. Then this bulb, LED bulb. So how it is produces light when the current passes through it? There is a microchip inside this bulb. So when the current passes through that microchip, it produces light. So here and here are also the bulbs. Then this motor. So when the current passes through this motor, how it rotates? The science behind this motor is very simple. There are 2 magnetic poles inside this motor. Between them there is a coil that is free to rotate. So when the current falls to that coil, the coil experiences a force and it rotates. So that is the science behind this motor. So this windmill is not only to learn about how we can produce electricity from batteries. We can use this when we get hot, because the wind makes from these winds are bit powerful. I will show it. Now I have switched off, so this paper doesn't move. But when I switch on, it moves as well. Again I switched off, it doesn't move. So this is the windmill I made for the STEM exhibition, and I hope this is a very good model for that STEM exhibition. Thank you. So this is the windmill that I made. The wires have gone inside these cardboards because it is nicer than going outside. Here are the battery packs. The wires have gone accordingly from these battery packs to this switch, then to this LED bulb, next to this LED bulb, then again to this LED bulb, and at last to this motor. So when I switching on, it doesn't work because I haven't inserted the batteries. So I'm going to do it. First I'm opening the first upper box, then I'm inserting the batteries. Then the second box. So now I have inserted the batteries. So it works. When it is in the darkness, it is like this.
My name is Kandy and I am from grade 7-3. I am going to make a tensability structure and explain about gravity. To start making the model, first I make two squares using the popsicle sticks. Next, I take another two popsicle sticks and put them together to make an L shape. Then I paste it on the middle of one edge of the square, like this, and you must also make another L shape and then paste it to the other square you made, just like this, and it will also produce something like that. Next, we must take one of them and turn it upside down and place it nicely like this. And then take a small string and paste it on these two on this edge. Next, I take the other end of the string and paste it on the other L shape. Then the final result will be like this. After that, when I take my hand off, it will fall to the side. To avoid that from falling to the back side, I will take a piece of string and place it on this side. To avoid the top part from falling to other sides, I tie a string on the opposite side of it. This is my final model and it doesn't bend or fall when I give a pressure from the top. A tensability structure is a system of isolated, compressed components within a network of cords that are under continuous tension. In this model, it stands without falling or bending, though they are not touching due to these strings. The tensability structure is an anti-gravitational structure. Gravity, also called gravitation, is the universal force of attraction acting between all matter. On Earth, all objects have a weight or downward force of gravity, proportional to their mass, which Earth's mass exerts on them. Gravity is measured by the acceleration that it gives to freely falling objects. Gravity is what holds the planet in orbit around the Sun and what keeps the Moon in orbit around the Earth. The gravitational pull of the moon pulls the seas towards it, causing the ocean tides. And gravity creates stars and planets by pulling together the materials from which they are made of. Thank you.
Good day to all. I'm Tenuli from 7-3 and this is my project. My model here is a tensegrity structure. The components in the structure are arranged in a clear fashion so that the strings are under continuous tension and compression so it appears to float. The reason it appears to float is because it replicates the force of gravity using the strings which are under continuous tension in two different directions. Here I have attached 4 strings tightly and the mechanism of the center of the model helps to maintain the push and pull of the strings. To make the mechanism, I fixed 2 V-shaped cardboard strips into each of the circle and tied a string to connect them together. So my model acts as a localized gravitational field. At first, when I made my model, when I kept a heavy object on it, it would not stand because the strings didn't have enough tension to hold the model. Then I rebuild it with equal length strings and I tightened it, and now if I keep a heavy object on it without collapsing, it will hold its weight. Gravity is the force that attracts 2 objects towards each other. It is what holds the planets in orbit around the Sun and what keeps the Moon orbit around Earth. Without gravity, the Earth's atmosphere would disappear because all the gases will start to float. And without gravity, we won't survive because oxygen will gradually vanish. There are many uses of gravity. The main uses are providing energy, keeping us from floating, and protecting us from asteroids. Did you know that our weight will be lighter on the Moon? The reason is the Earth's gravity is heavier than the Moon's gravity, thus making our weight lighter on the Moon. With that, I wrap up my presentation. Thank you. Good day to you all. My name is Sanali and I am a grade 7 student. Today I am going to explain about my model, the tensegrity structure. What is tensegrity? Tensegrity is a structure based on systems of isolated components under continuous tension. It was developed by Buckminster Fuller. The tensegrity structures are used in the Needle Tower, Munich Olympic Stadium for reliable modeling, and in the Kurilpa Bridge. A tensegrity structure floats due to the balance and tension of the strings. The string in the middle helps to keep the 2 structures pressed together tightly, thus creating a tension in the strings. If I keep this toy on top of the structure will hold its weight because there is a gravitational pull and push that makes my structure stable to put this toy's weight. What is gravity? Gravity is the invisible force that pushes or pulls an object together. Gravity provides energy, saves Earth from collision against asteroids, helps us to walk on earth without floating away, and helps in investigation for unseen planets. Did you know that even though Buckminster Fuller developed the transecurity structure, it was Kenneth Nelson, his student, who created the first structure in 1949. Thank you for watching my presentation. Have a good day.
I'm going to make a catapult, and these are the things you need to make it. Some popsicle sticks, a super glue, some rubber bands, and a bottle lid. So first, I'm going to take 4 popsicle sticks and make a square shape. So now I'm going to take another 4 popsicle sticks and cross 2 like this from the top, and the other 2 also like that, and paste it on the figure. Now I made 2 of those things I told you. I crossed the 2 popsicle sticks on this one, and here also I crossed the 2 popsicle sticks. Now I pasted the 2 pair of popsicle sticks like this. And now I'm going to take 2 other popsicle sticks and paste one on the top and one on the bottom. So now that I pasted these 2 popsicle sticks on my model, I'm going to take another popsicle stick and the bottle lid I took, and I'm going to paste it on the popsicle stick with some super glue. So now I pasted the lid on the popsicle stick, and now I'm going to insert it into the model. I have to keep the bottle lid on this popsicle stick, and then I have to bring this other end on the middle stick like this. And now I'm going to insert a rubber band into it. So now I inserted the rubber band. I put it from here, and then I took it out from the end of this popsicle stick, and now I'm going to try it out. I'm going to take a ball of paper, cardboard, and I'm going to keep it here, and I'm going to pull it like this and release it so the paper ball goes. So this is my catapult, and this is a type of a lever. So the paper ball moved along a curved path under the action of gravity, and this type of motion is called projectile motion. And this path it moved is called its trajectory. Then the trajectory of the paper ball has a parabolic shape.
Model that works with air pressure, and I made it with 9 craft sticks and 2 syringes and a thread because I didn't have an aluminium wire, and I also used this starting. And let's see how it works with air pressure. So in this model we have 2 syringes, and when we press down this one, the other one goes up, and that is because of the air in the cylinder get pressed down as well, and that is where we create air pressure. And this cylinder goes up because of the air pressure we just created. What is air pressure? Air pressure is the weight of air in our atmosphere pressing down to the earth. It can be compared to the weight of water pressing down on a person when they dive into deep water. People can feel the effect of air pressure on their ears when they hike up a large mountain. Unit of the pressure is Pascal. So air pressure is essential for breathing, and also some other examples for air pressure is blowing a balloon, a vacuum cleaner, drinking a soft drink with the help of a straw, and that is air pressure.
This is a dump truck. Dump trucks are used to transport stuff like sand, gravel, and cement, and are normally powered by hydraulics, which can also be referred to as water pressure. But this model works using pneumatic power, which is air pressure. So for this model, I have used 2 syringes. This syringe is filled with air, and as we push the piston of the syringe, the air travels through the tube into the other syringe, which is glued to the body of the dump truck. And as the piston of the other syringe lifts, it lifts the body of the dump truck also, causing the items in the body of the dump truck to fall to the ground. Daily examples of air pressure in day-to-day life are blowing a balloon, pumping air into the into the tires of a car, bicycle, any vehicle, vacuum cleaners, and stuff like that.
I'm Devsara Vijay Sundara from grade 7-5. Today I'm going to introduce the pneumatic model which I made. So for that we need to prepare its structure first. For that we need to prepare 2 triangles with popsicle sticks. And as you can see, the 2 triangles are connected with 3 other popsicle sticks, 2 at the base and 1 at the top. After preparing the structure, we need to prepare its pneumatic model. So for that we need to connect 2 cylinders with a flexible tube. When connecting these 2 cylinders, one should be filled with air and the other shouldn't be filled with air. And now what I'm going to do is that I'm going to press this arm of the cylinder. And as you can see, when I press this arm, the arm of the other cylinder moves upwards. So what's happening is that when I press this arm, the air below is pressurized and a force is applied through this tube and to the other cylinder. And due to that force, the arm of the cylinder starts moving. This is simply known as air pressure. Air pressure, imagine that you're outside on a windy day and wind is blowing very hard and you can feel that a force is applied on you. That is simply known as air pressure. Air pressure is used in many day-to-day applications such as the pressure cooker and the bicycle pump. Also, air pressure is used in some other vehicles such as bus, bicycle and car. Also when we are blowing a balloon and even when we are breathing. This concept is a wonderful concept which is used in many day-to-day activities. Thank you.
Hi everyone, I'm Ragini Adhikaran. Today I'm going to talk about the rubber band powered car. You have probably lodged a rubber band at least once. Did you ever suspect that rubber bands could also be a fun way to learn about engineering? This is my rubber band powered car. I made it using 2 popsicle sticks, 2 bottle lids, straws, toothpicks and rubber bands. I took 2 wheels and axle from an old toy car to use for backside wheels instead of bottle lids because I couldn't find 4 bottle lids. I used a toothpick as the axle of the car and the bottle lids as the wheels. And the rubber band is the main power source. Let's see how I made this rubber band powered car. I took two popsicle sticks and pasted them together, and I cut a piece of straw about 3.5 centimeters and a toothpick about 7 centimeters. And I pasted two plastic bottle caps with a toothpick and straw. I have pasted them together. Then I insert my axle and the wheels. After this, I cut two small toothpicks and pasted one toothpick in the middle of the front part and the other in the middle of the back part. Finally, connect pointer 1 and pointer 2 with the rubber band and twist the pointer 2 multiple times. Having a little gap between the wheels and stroke is important. A large gap will make the wheels wobble and causing the car to veer left or right, and overall reducing the distance traveled. Finally, we should wind up the car's axle. We stretch the rubber band, then the car should move. Let's see how it happens. When we wind up the car's axle, we stretch the rubber band and store potential energy. If we release it, the rubber band starts to unwind and the stored potential energy transforms to kinetic energy, making the car move forward. We all call it potential energy. Elastic potential energy is the energy stored in elastic materials as the result of the stretching and compressing. Do you know that in the coil spring of a wind-up clock, an Archer stretched bow, a bent diving board, and catapult also use this potential energy? Think of the fuel economy for this rubber band powered car. Gasoline powered cars calculate their fuel economy in miles per gallon, or how many miles the car can travel on 1 gallon of fuel. This car uses a stretched rubber band as the energy source instead of gasoline. In future, there will be rubber band powered cars instead of fuel cars because this is very useful. Thank you.
I'm Diana Jaivira and I'm from Hillwood College. Today I'm going to talk about towers. Towers are buildings that are built not to be habitable but to serve other functions using the height of the tower. This is my model, a model that represents the Burj Khalifa Tower in Dubai. The Burj Khalifa Tower is one of the tallest towers in the world. I made my model using straws, A4 papers and cardboard. I used some pillars to make the tower strong and stable. And I used this to keep it strong. I had to use this to keep the tower stable, and it was a little hard fixing these pillars and making sure they are properly fixed. This is a little different than the Burj Khalifa tower since I added this bottom part. There are many types of towers such as transmission towers which transmit electric power over large distances, water towers which helps with water needs, cooling towers which provides ventilation and helps in air conditioning, wind turbine towers which generate electricity, and telecommunication and mobile towers which helps in the function of wireless communication devices.
I am Damsini Munazin from grade 8-5. So today I'm going to talk about the tower model I created and the tower models around the world. So this is my tower model which I created for this exhibition. I made this model according to the Burj Khalifa tower structure. To make this tower creative, I made a triangular shaped entrance as you can see here. And I used colorful straws to make it attractive. To make the tower stand still, I used popsicle sticks as you can see, and I pasted straws front and behind the tower. So the little color, pink color square over there is just the entrance for the tower. So if I talk about the challenges I faced, it was kind of challenging to stick the straws together, but somehow I managed to do it. So this is all about my tower model. So next I'm going to talk about the tower models in the world. So in the model world, people are planning to create amazing, attractive, beautiful towers. We have many types of towers in the world like the Eiffel Tower in Paris, Nelum Kurul in Sri Lanka, Burj Khalifa in Dubai, CN Tower in Toronto, Big Ben in England, and the Leaning Tower of Pisa. So there are many types of towers which is used for our purpose, like the water towers, cooling towers, wind turbine towers, transmission towers, and many more. Most of the towers in the world are used to make the tourists local or the local citizens for their entertainment. Some are used as office working and others are used for domestic purposes like electricity or water supply. So this is all about my tower model and creations of towers in the world. Hope you enjoyed it. Thank you.